Okay, so we're moving on into a concept called stoichiometry, and you've heard me talk about this in the past, but now we're here. And the nice thing about stoichiometry is that it really just kind of takes all the little pieces that we've kind of learned throughout the course and puts them all together in sort of one concept. And so as we've been going throughout the course, I've been giving you these little pieces and teaching you how to do things a particular way so that it fits really nice with how we do stoichiometry. And hopefully makes this a little bit more streamlined for you. What we need to know as kind of just an introduction to stoichiometry is that there's three types of stoichiometry. There's what we call gravimetric stoich, which basically deals with kind of mostly masses, or masses exclusively. We have gas stoichiometry, which deals with pressures and temperatures and those kinds of things. And then we've got solution stoich, which deals with more kind of along the lines of concentrations and things that have been dissolved in water and stuff. So those are the three types, but the nice thing about stoichiometry is it doesn't matter what type of stoichiometry we're doing, the rules to doing stoichiometry are exactly the same. And so you need to make note of that somewhere in your notes, that the rules to stoichiometry are the same no matter what type we're doing. And here are the rules. So just write those down, have those handy as I go through the examples that I'm going to go through with you. So that you can make sure that we're following the rules properly, and also so that you can see that, hey, it doesn't matter what kind of stoichiometry we're doing, the rules are the same. So I'll be right back in the next clip with an example, and we're going to get started with the first type, which is gravimetric stoichiometry. So I'll be right back. So here's our first example on gravimetric stoichiometry. What you see here in black is what would be given to you in the question, and if you take a look in your practice booklet, in the gravimetric stoichiometry section, the very first question, question number 1, that's this guy right here. So we're just going to do this one together. Everything in blue is what you would need to write down. So hopefully you have, as I mentioned before, the rules to stoichiometry out in front of you so that you can follow along. It's really important that you have those rules out in front so that as you start to do these, that you can follow them. You'll find as you do a bunch that you won't need to have the rules in front of you moving forward, but beginning and starting out, having those rules out in front is really important. Okay, so rule number 1 that we talked about in the previous clip was that you need to write a balanced chemical equation. And I had the word balanced underlined, and it's because if the reaction isn't balanced, then it's going to throw your calculations off in lots of cases. So you must have a balanced chemical reaction. That's why we've practiced that for so long. So here I read this sentence and I have to generate what the reaction is out of this. So it says find the mass of Al2O3 produced, so I know that Al2O3 is a product because it tells me, by 10 grams of aluminum solid reacting with excess oxygen. So I know my reactants are aluminum solid and oxygen gas. So I've written that down here, and you can see I've written my balanced chemical equation. So that's step number 1. Now, a couple other things that I like to do that aren't necessarily rules, but I find that it's really helpful in making sure that my stoichiometry is very organized and easy to follow, is I like to identify 2 things. First, the question will always give me information for a particular substance, a substance that I like to refer to as the given. Okay, it's the thing I've been given information for. And then the question always requires me to find information out of some other compound. And that's essentially what stoichiometry really is you're given a set of parameters, either masses or temperatures and pressures or concentrations, volumes, whatever it is that they give you, and you have to convert that thing that you're given into something that they're requiring you to find out for that given reaction. And so there's always something that I'm being asked to calculate, or the required is what I like to call it. And so I like to identify what is my given and what is my required. So I am given 10 grams of aluminum in this question. And so aluminum solid is my given, and so that's how I like to label it. It's just up above like that. And then what I'll always do is I'll write down the information that I was given in the question right underneath of it, so that I know that this is not 10 grams of oxygen or 10 grams of aluminum oxide. It is 10 grams of aluminum, so that I can keep that straight. And any time, and we've established this many times throughout chemistry, is any time that we are given a mass, most likely you are going to need to have the molar mass. And so in stoichiometry, it's no different. If you're given a mass in a question, or you're asked to calculate a mass in a question, always have the molar mass written down below. And so here is the molar mass of aluminum, You just grab that out of the periodic table. Now, something to note that kids oftentimes really like to do that's incorrect is because these reactions are balanced, we have these coefficients in front. And when kids calculate molar mass, for some reason they love to include this coefficient in front in their molar mass calculation. So they'll look at the periodic table, they'll say, okay, aluminum's got a molar mass of 26.98 grams per mole, and because I've got 4 of them, I have to times that by 4. And you don't do that. This 4 gets included in the calculations in stoichiometry later that I'll show you in just a minute. So all you need is just the molar mass of aluminum. The mole part of molar mass is included in that number. So we're not saying, what we're saying is that we have 26.98 grams for every mole of aluminum that we have. We have to figure out how many moles of aluminum we actually have, and to do that we need this number in the grams per mole unit. So make sure that you're watching out for that and you don't fall into that trap. Then I like to identify what my required is. What is the question asking me to calculate? And it says right here, find the mass of aluminum oxide. So that's my required. And I stick an M with a question mark beside it, denoting that's what I'm looking for. I need to find the mass of aluminum oxide. I've got a big M here because I need the molar mass of that substance. If it is asking for a mass, I'm going to need the molar mass of that. Writing the molar mass here and calculating that out. Turns out to be 101.96 grams per mole. So now my question's set up. I've got this stuff set up here at the top, and now I can start doing my calculations. So step number 2 in stoichiometry is calculate the moles of the given. Now if I'm calculating the moles of the given, which is in this case aluminum has some numbers associated with it. I need to make sure that I'm using the numbers for aluminum. If I'm calculating the moles of aluminum, it makes no sense for me to use the molar mass of bismuth or the molar mass of aluminum oxide. I need to make sure that things are organized. And so that's why I also have this organized here, so that I know and I can remember, okay, these are the numbers that I need to use to calculate the moles of my given, which in this case is aluminum. So to do that, I've got 10 grams of aluminum here. And I just use my molar mass to calculate the moles of aluminum. And we've done this. We did this in Science 10, and we've done this at the beginning of this semester as well. And you can see here, all I'm doing is unit analysis. So I put the 26.98 grams on the bottom, and that's because I want these grams to cancel out. And you can see I'm left with moles of aluminum here. And so I plug that into my calculator, and I get 0.37 moles of aluminum. Notice this is a rounded number in your calculator. If you punch this in, you'll notice it's a big, long, irrational number. Please make sure that when you're doing your stoichiometry calculations, that you don't, in your calculations, use any rounded numbers. It's okay to write a rounded number on the page. Nobody wants to write out 15 digits or 10 digits on a paper. But keep that big, long number in your calculator for your calculations moving forward. So now, I've got 0.37 moles of aluminum. That's where I'm at. And step number 3 in stoichiometry says you need to convert the moles of the given, which is this right here, into the moles of the required, which is in this question, aluminum oxide. So the way that I do that is I use a strategy called the mole ratio. And so the mole ratio is simply how many moles of my required do I have divided by how many moles of my given do I have in the balanced chemical equation. And so that's where these coefficients come into play, is I've got 2 moles in my balanced equation. What this reaction is saying is that it's saying if I react 4 moles of aluminum, I'm going to produce 2 moles of aluminum oxide, which just means that whatever amount of aluminum I have here in moles, in this case it's 0.37. I don't actually have 4 moles of aluminum. I have 0.37 moles of aluminum. But what I know is that whatever number of moles of aluminum I have here, the amount of aluminum oxide that I'm going to produce is half that much. And so if I have 0.37 moles of aluminum, then the ratio I'm going to use is going to denote that. So I have the moles of the required on the top over the moles of the given on the bottom. And so 2 moles divided by 4 moles is just going to half this number, 0.37. In your calculator again, use the big long numbers, and you'll get 0.19 moles of aluminum oxide. And so that's step number 3, is converting the moles of your given into the moles of the required. If this number here was 8, then this number here would be 4. If this number here was 10, this number here would be 5. It's not, it's 0.37, so this number here is going to be 0.19. And again, remember, these are rounded numbers, and so it doesn't really look like it's totally half, but these are big long numbers in your calculator, and so just make sure that you're using those big long numbers. Now step number 4 is I take the moles of my required now that I've calculated in step 3, and I'm going to calculate what the question is asking for. So I have the moles of aluminum oxide. The question asks for the mass of aluminum oxide. So in order to do that, I'm going to use the molar mass of aluminum oxide. Notice that if I'm looking for something for aluminum oxide, I've got to use things that are associated with that compound. So the moles of aluminum oxide and the molar mass of aluminum oxide is what is going to get me the mass of aluminum oxide. And again, through unit analysis, and we've done lots of questions like these in the past, I have 101.96 grams on the top, my moles goes on the bottom so that my moles can cancel, and you can see now I'm left with grams of aluminum oxide, and I plug that into my calculator and I get 18.9 grams of aluminum oxide. And that's my answer. And so you can see each step here of stoichiometry is properly labeled. This right here, if you want to, you can write this down as the mole ratio is just required over given. That's sort of the short way of saying it. It's the coefficient of the required divided by the coefficient of the given. And coefficients in chemistry always mean moles. So 2 moles of aluminum oxide divided by 4 moles of aluminum. And then you're well on your way. So this is kind of the long way to do it. There's actually a shorter way, and maybe as I've kind of been doing my explanation here, you've noticed that there's a few redundancies in terms of what I'm writing on the paper. You can see I've written 0.37 twice, 0.19 twice, and oftentimes, we don't even really need to write these down at all. And so what you can see is mathematically what I've done here is I've gone 10 divided by 26.98 times by 2 divided by 4 times by 101.96. And so I can shorten this out and do this in a bit of a shortened way, and you'll see me do the remainder of my stoichiometry questions like this, and you too should be proficient at this way. If you prefer this way, that's fine. You can do it the longer way, but what I find is most kids end up migrating towards the shorter way anyways, because it is a little bit quicker in terms of just how much you have to write down. So if I take a look at kind of erasing the stuff that doesn't really matter, you can see that I don't need to write these 0.37s down. I can just keep that number in my calculator and carry on with my calculation. And so here I've just got this times by 2 moles over 4 moles. And so now all of that is gone. And then my last one here is, again, I don't need to write that 0.19. I can just take my molar mass and write that down there. And so now what you can see here is you can see there's, so again, some unit analysis here that takes place, and things cancel out and it all works out. So let me show you how this goes. The grams here cancel, and I'm left with moles of aluminum. And then my moles of aluminum are on the bottom here as well, so I can cancel those out. And now I'm left with moles of aluminum oxide. And then my moles here cancel, and now I'm left with grams of aluminum oxide. And if you plug this into your calculator like this, 10 divided by 26.98 times 2 divided by 4 times 101.96, you're going to find you're going to get the exact same answer. And so this is a lot shorter of a way to do this, and you can see the steps to stoichiometry are still present. So here's step number 2, step number 3, and step number 4. So I'll be right back with another example. We'll do one more, doing it this way, the shorter way. So hang with me and I'll be right back. All right guys, so here's our next example. We have here in black again, the stuff that's given to us in the question. This is question number 2 in your booklet, just underneath the one that we just did. And it says, what mass of H2 is needed to produce 100 grams of H2O liquid? And so my reaction here is simply, if I've got hydrogen and I'm using hydrogen in a reaction to produce water, obviously I have to react it with oxygen, because water has oxygen in it. And so here's my balanced chemical equation, and you can see I've balanced it with the appropriate coefficients in place. And then what I've done is I've identified my given and my required. First of all, it says what mass of H2 is needed, so that's obviously what the question is requiring me to find out. So H2 is my required. Mass is equal to, I don't know, and here's my molar mass for that substance, 2.02 grams per mole. Again, notice that if I have numbers down here, I have to use them in the calculations of my molar mass, but I do not use my coefficient in front to calculate the molar mass. Coming over here, it says how much to produce 100 grams of water, so obviously 100 grams of water is what's given to me in the question. So this is my given, mass is 100 grams, molar mass is 18.02 grams per mole when I calculate the molar mass of water using the periodic table. And again, here's my stoichiometry, written out this time in the short way. And you can see here as well where the steps to stoichiometry are. So step number 2, find the moles of the given, is right there. That's the moles of the given when I do that calculation. And then convert the moles of the given into the moles of the required using the mole ratio. That's step number 3. And then using the moles of the required I just calculated, convert that or calculate the answer that the question's looking for, which is step number 4, right there. Okay. Now, if you take a look at this again, we do some unit analysis. What we need to do is calculate or cancel out these grams right there, and then you can see the moles of H2 cancel out here and here. And so those are gone, and then the moles cancel out there, leaving behind for me grams of H2. Now sometimes kids will ask, they'll say, well, hey, look at this mole ratio. It's times 2 divided by 2. That doesn't matter. That's just 1. I can just skip that step. And if you want to do that in your calculator, that's fine. But on the page, you still have to write down the mole ratio. Because if you take a look at this, the mole ratio essentially is, what it's doing is it's doing the conversion for you. Now in this sense, 2 moles of this makes 2 moles of this. Now I don't have exactly 2 moles of any of these substances, but the ratio, yes, is a 1-to-1 ratio. But this step is still important because it's showing that you are converting the moles of the given into the moles of the required. And so if this is redundant in the calculator, fine, you can skip that. But on the page, you must write down what the mole ratio is, and in this case, it's 2 moles of hydrogen over 2 moles of water, to show that you are converting whatever moles of the given you have into the moles of the required. And so that's a really necessary step to show, so that you are showing that you know that that's what's happening and that that's an important step. I also get questions like, do I have to write in all this stuff, like you're writing water and hydrogen? Do I have to write all that stuff in? And, as time goes on, I would say initially, yes, write it in. But as time goes on and we do lots of these problems and you're doing lots of practice, you're going to find me sort of omitting the water and the hydrogen and the water on the bottom, just because it speeds up the process a little bit. Sometimes these questions can take a little while, and so what we can do to shorten them a little bit is okay, and I'm okay with that. What you most definitely cannot do is leave out units. You must leave in the grams and the moles. You must put those in and show that those are being canceled out. And again, to reiterate, you cannot skip the step of the mole ratio if it looks like it's redundant. You must still show that you are making that conversion happen. And so sometimes I will write in these just because I think it's a good habit to have, and it does show, hey, this conversion is definitely taking place. The last thing I didn't mention in the last clip that I will mention here is that when you get your answer, you must make sure that you are rounding to the correct number of significant digits. So in this question here, it gives me a number of 100 grams. And that number has 3 significant digits if you count them. And so my answer must have 3 significant digits. And so if you go back to the previous clip, you'll see that I've followed that for that question, and it was supposed to have 3 significant digits there. And that's it, guys, for this one. So good luck in the practice. Thanks for watching.